Welcome everyone to the Data4Energy session in Data Week. Thank you, first of all, to the organizers and also, of course, to Joana Badea from Gecko, that she has been supporting us behind the scenes. My name is Luis Viguer. I am project manager at ETRA and the Synergy project coordinator. And I will be moderating this session. And of course, I will start introducing the agenda and then also the Synergy project. So we have gathered 4 projects from the ICT 11 call on Big Data Solutions for Energy. So from Synergy, it will be me, and then we will give the floor to Fenaretti, Lampataki. Then it will be the turn for Platoon, that will be presented by Philippe Calvez. After, it will be Javier Baliño from Atos presenting BD4 Open project. And next, Nathalie Samovic from BD4Energy project. And finally, it will be Ruben Costa, also from Knowledge Leads, also presenting Synergy project. And finally, we will have questions and answers session and a World Cafe. Before I start my presentation, some quick tips. We will launch some polls, okay, after my presentation, after Javier's presentation, and after Ruben's presentation. So please check the WOBA poll section, okay, in order to interact with us, please. We will value a lot your feedback. And for the Q&A sessions, please, you can either go to the WOBA Q&A section, or you can post your questions in the Zoom chat. So very briefly, Synergy project started early 2020. It has a duration of 4 years. We are 24 partners from 9 different countries, including 5 demo sites, and with a total budget of almost 13 million euros. Our vision is to provide a novel framework and reference big data architecture, okay, for the electricity domain in order to gather data from a variety of sources throughout the electricity value chain, and thus, let's say, shift from an individual, let's say, analytics and intelligence decision-making to a collective intelligence level. So our targets are, first of all, to deliver this big data platform, but also we are going to provide an AI analytics marketplace. So this data exchange is also a target for us to build it in an innovative, secure, privacy preserving and IPR respecting way. Then we will also develop new energy services, okay, to satisfy the new emerging stakeholders' needs in the electricity value chain. Then bring forward these novel collaborative business models driven by this big data sharing, and also, of course, to validate and to promote the project outcomes. So to do this, we are 24 partners from 9 different countries, covering energy systems and services domain, also big data and analytics domain, and also the business innovation and energy markets domain. We have 5 different demo countries, okay, in order to demonstrate the project outcomes in Austria, Croatia, Finland, Greece, and Spain, and we have, as I mentioned, stakeholders covering the whole value chain, from network operators to retailers and prosumers. we are going to develop 13 energy apps that will be fed by this big data platform and AI analytics. So in the first row, you will see the applications that are aimed at the network operators and the renewables operators. Mainly, these applications are focused on network management and renewables operation and maintenance. Then in the second row, you have the applications that are aimed at the electricity retailers and aggregators. And these applications are mainly focused on demand response management, but also focused on retailers' portfolio management, and also for personalized energy analytics for consumers and prosumers. In the bottom row, we have the applications that are aimed to energy services companies, facility managers, and public authorities. And these applications are focused mainly on urban building and facility management, dealing with several topics such as renovation, self-consumption, and monitoring management and support. So that's it from my side. Thank you very much for your attention. And now, please, you can move to the WOBA poll section, in order to interact with us. So I will leave you a couple of minutes to do that, and then we'll resume and give the floor to the next panelist. Okay, so I think we can move on with our next panelist. Fenaretti, welcome, and please, the floor is yours.
Thank you, Luis. Good morning, everyone. Just give me 1 second to share my slides. Okay, so in the next minutes, I'm going to provide you a more technical overview of all the things we have been doing in Synergy over the last period. I am Fenaretti from Suite 5 Data Intelligence Solutions. I'm the technical director of the company that specializes on data platforms and AI solutions, and I'm the technical coordinator of the Synergy project. So, what is Synergy all about? Luis has already given you a thorough view of what we have been doing, what are the objectives, and what are our energy applications. If we want to look at the whole, let's say, ecosystem, we are trying to facilitate the interactions, data sharing, and data analytics for the whole electricity data value chain stakeholders who are able to come to our big data platform and AI marketplace, create what we call data checking pipelines in order to ensure that the data can be properly handled in the platform, to ensure that the data quality can be increased, and also we allow them to control the access to their data assets in a way that is enforced in an end-to-end manner on the platform. In parallel, they can acquire data assets, data sets, but also additional assets, as we will see in a while, through smart contracts that are signed between all the different involved parties. At the same time, they can run analytics pipelines utilizing both their own data, but also data they have acquired by other stakeholders of the electricity data value chain. The different energy applications that we saw earlier They can interact with the platform, they can upload their own application data. Most importantly, they can receive and retrieve data from the core platform. They always based on smart contracts that are signed with the different stakeholders in order to ensure that they have legitimate access according to specific contract terms to the specific data. They can retrieve the data through customizable APIs, and we will see in a moment how we allow this to happen. They can obviously also run analytics pipelines, and they can retrieve the results as well. Our reference architecture, it is on 3 main layers, as we can say. And I noticed that for some reason, now it worked. We have the cloud infrastructure in which the core of the platform lies. Different components and different services are placed on that layer in parallel in order to, since the data may be uploaded in an encrypted way on the platform, we are offering secure experimentation playgrounds per organization. The whole platform offers organization-based access, so different members of the organization can access the Synergy platform. We are offering secure experimentation playgrounds that are essentially VMs that are spawned for the different organizations in order to securely store their data and run analytics. In parallel, we are offering secure on-premise. We are offering on-premise environments that are installed either on server environments or on the edge on different gateways with, let's say, the precondition that they are able to run Docker in order to ensure that the different stakeholders can run certain functionalities of the platform locally. Either these functionalities refer to how the data are prepared and then uploaded to the platform in order to ensure end-to-end data security, but also it may refer to the fact that many stakeholders may want their data never to leave their premises, so they can be stored on the on-premise environments, and analytics pipelines can be also executed on the on-premise environments. The energy applications, as already mentioned, lie on the top in a way, and they can exchange data with the cloud infrastructure. A more detailed view of the reference architecture can be seen here. I will not dive into the details on what is behind each and every service and each and every component you can see either on the cloud platform, on the secure experimentation playground, or on the on-premise environments. There are many different, let's say, services that are Dockerized, and they are orchestrated through our master controller in order to ensure that the appropriate pipelines can be executed as needed according to the specific schedule to wherever the data provider the organization has decided. I am right now going to move into some further details that we want to provide on some of the data services. It all starts with the data collection services bundle that allows the stakeholders to configure how they want to send their data. So data ingestion may happen on the cloud, on-premise, or on the edge. The data can be transformed and their quality is ensured through mappings to the common information model and cleaning functions we support. Data security is all about data minimization, data access control, attribute-based access control that is ensured for at any moment the data may be utilized, and end-to-end data encryption to ensure security during at the time the data are transferred as well. We are offering the data sharing services bundle that essentially includes the data and AI marketplace for sharing not only data sets but also trained AI, machine learning and deep learning models, sharing results of such models and of pipelines in a secure way according to the licenses and the IPR that the different stakeholders have provided. Obviously, we're offering data matchmaking services to search for those assets. And at any moment, the stakeholder wants to acquire a specific asset, we are following a process we will see in a moment that is all about how the asset's contracts life cycle is managed. Since the contracts may involve more than one parties, since we are talking about assets like results that can come out of a pipeline that includes different machine learning models that come from one stakeholders, many different data sets that may come from multiple stakeholders, we always need to have in mind that in the end of the day, the contracts may not be just bilaterally signed, but they may involve multiple parties. And to that end, if such contracts have a cost, we need to ensure that all the different parties that are involved are going to be properly compensated through the remuneration policies mechanism we are following. We have a data analytics services bundle that is all about configuring and executing analytics pipelines. The execution may happen on the cloud, on premise, or on edge. Such pipelines may include different trained energy data analytics blocks we are offering in order to solve different problems that we are facing in Synergy and offer generic added value to different electricity data value chain stakeholders. The data and the results can be visualized in order for the stakeholders to gain insights into what, let's say, the data are saying and to explore visually the results. We're also going to offer, but not in our initial release, secure multi-party computation, since the data may be stored only locally by different stakeholders. Secure multi-party computations are also going to be provided in order to allow certain computations to happen and KPIs to be calculated. And last but not least, we have the data governance services and the platform management services. The data governance services offer additional data lineage services to follow the provenance of the data and the different data assets. And the SIM Lifecycle Manager is essentially a functionality that allows us to manage the whole life cycle of the common information model. As new needs may arise, as stakeholders come to the Synergy platform, to add as many fields as needed, as many concepts as needed, in order to ensure that nothing will break in respect to the data that have been already stored on the platform. When it comes to the platform management, obviously we're offering authentication, authorization, security services. We have a common identity provider for the platform and the different energy applications. We are offering an API gateway to ensure that we can properly handle all the requests and we can expose at any moment customized endpoints, API endpoints to serve only the data that one stakeholder may need. We should not forget that the data that a stakeholder uploads as a data provider are not essentially what the data consumer needs. And in order to bridge this gap, we're offering many ways to the users to define and configure how they want to retrieve certain data and results. And obviously, all the functionality of the platform is orchestrated. The services are orchestrated on the cloud and on and are sent to the on-premise environments for execution through Kubernetes cluster. Diving into more detail on certain, let's say, core services bundles in order to show how the different data providers can upload data, how they can search and assign contracts, and how they can run analytics. Just a few words. When it comes to uploading data, we're offering 5 data ingestion methods. Files can be uploaded in different formats. The data can be retrieved from the APIs that different stakeholders have already exposed, and we don't request for any change on those APIs. As I'm going to explain in a moment, we can the different stakeholders can push data on the platform, utilizing the platform's APIs and customizing an endpoint according to what exactly they intend to send to the platform. We are supporting data ingestion through the stakeholders Kafka mechanisms, since they may already have a streaming mechanism in place and the platform can connect to that specific mechanism, or if they don't have in place a streaming mechanism, we are also offering the option of utilizing the platform's Kafka data ingestion mechanism. We are fully separating the design time and how the data check-in pipelines need to be configured once versus the execution time that those pipelines are executed either once on scheduled time frames based on events. And this configuration that happens at design time once, it happens through the Synergy platform user interface, and it includes essentially how the data will be ingested, providing all the necessary information for each of these different methods. The user, obviously, the data provider defines the schedule and all the necessary details about how the pipeline needs to be executed. The next step is about the data mapping and transformation, where the data provider defines, supported by us, how his data, to which we do not require any change on the backend systems or the APIs that, and the mechanisms they already have, how their data can be mapped to the common information model we have created that is based on different standards, as you can see, different IEC standards, OpenEDR, SRF, IFC, etc. How the data are mapped, and he provides certain details about the data. What are the measurement units, for example, in order for us to be able to handle all the necessary transformations depending on the data type, date time transformations as well to UTC, etc. The user may also optionally decide to clean the data. Cleaning the data means providing instructions how outliers can be handled, missing data, missing values can be handled, how data can be anonymized, depending on whether they are quasi-identifiers, whether they are sensitive data, etc., whether data should be encrypted, and this is available only for the on-premise version. He needs to define the access control policies, define the metadata, and how the data will be in the end stored locally or on the cloud. Alternative pipelines may be followed, since a stakeholder may want to not follow all the steps. This is something that he can configure on the platform. When the time comes for execution, different microservices are spawned for execution, either on the cloud or locally, with the help of the master controller and the resource orchestrator. Execution logs are available in order for the data provider to know what happened on their data, and obviously, at any time data become available, they are also transferred to the secure experimentation playground in order to be available for analytics. When it comes to data sharing, we are offering a data and AI marketplace to explore different data assets, to search within the data, to recommend, let's say, additional data assets of interest. And when a stakeholder finds exactly what he wants to retrieve, he can request for quotation for data assets he has already placed in his cart. He can, the data provider or providers can check this request for their data asset. They prepare a draft contract that is written on the blockchain, on the DLT-based contract lifecycle manager we are offering. It needs to be noted that no actual data are written on the blockchain. The hashed contract terms and the price are written along with the details of the specific contract, and only the organization's managers can really sign those transactions that involve the contracts. The data consumer checks the contracts, and he can decide whether he accepts the contracts, whether he wants to negotiate this contract, or he rejects the contract. As soon as the different, let's say, involved parties reach consensus, reach an agreement, this contract needs to be settled, the payment must be made if there is a cost, and afterwards this contract is activated on the platform. There is a distinction between the bilateral contracts and the multi-party contracts. In the multi-party contracts, the Synergy platform has a far more active role. Once the data are acquired by a stakeholder, as I already mentioned, he can define his own, let's say, retrieval queries to define what exactly he wants to retrieve from the data, and the access policies are obviously enforced. And they are enforced on the marketplace as well, everywhere that someone requests for data. The transfer of the actual, the acquired data set, it really depends on the contract terms that are enforced in the platform in an end-to-end way. When it comes to data analytics, we're offering a set of basic machine learning, deep learning algorithms that are offered in an out-of-the-box manner from Spark MLE, Sklearn, and TensorFlow over Keras. We are offering also a number of pre-trained machine learning and deep learning models in order to solve specific problems of the electricity data value chain, generation forecasting, demand forecasting, flexibility forecasting, just to name some very, very few examples of the things we have been doing. The design time is also separated from the execution time in order to ensure that those pipelines are defined once. They are defined as directly DAGs. The user needs to define the input, he needs to define different data manipulation functions he wants to apply on the data. He defines additional inputs, for example, data manipulation can be to create new columns, to join different data sets. He can define different machine learning pipelines in order to bring together for us the platform to handle in a different way how encoders with training, then training a machine learning algorithm, applying the trained model and evaluating the trained model is handled. If we had chosen a pre-trained machine learning to deep learning model, this would appear differently, obviously, and the output, if he wants a visualization that he can configure as he wants in order to be visible on the Synergy platform, or he can configure how the data will be retrieved through the platform's APIs. The execution of such a pipeline happens according to a schedule. Again, the customized adaptive microservice is spawned for execution either in the cloud on the secure experimentation playground or locally if the data do not leave the premises. Execution logs, again, are always stored in order for the user to know what went wrong, and the output of a pipeline is always stored and can be also potentially treated as a data asset that is available through the marketplace. I know that I went very, very quickly because I don't have a lot of time at my disposal. And to summarize, what are the key achievements we have so far? The reference architecture and the detailed design is already in place. We have defined different business models in order to ensure that what we are doing brings added value to the different stakeholders of the electricity data value chain. The development activity, the early release of the different building blocks that I presented earlier are already in place. The common information model is under finalization. And in the end of next month, we are launching the beta release of our integrated platform, a unique, let's say, interface which is the entry point for any stakeholder to utilize all our functionalities. And sorry for rushing in the end, but I didn't want to take even more time. So thank you all for your attention. I'm at your disposal for any question you may have. And I would like to give actually the floor back to you, Luis, in order to continue with the next presentation.
Thank you very much, Fenaretti. Thanks for your comprehensive and interesting presentation. I will take the chance to remember everyone, all the attendees, that you can go to WOBA poll section, okay, and check all the surveys that Joanna Badea is publishing, and you can also go to the Q&A section to let us know your questions, or you can do it also through our Zoom chat, okay, so that we can address your questions at the end of this conference. Okay, so now it will be Philippe Calvez from ENGIE. Hello, Philippe. If you are ready, the floor is yours.
Yeah, let me, thank you, Luis. Let me share my screen. Hopefully it works. I will put like this. Sure. And put in the full screen. So are you able to see the screen?
Yes, thank you.
Okay, perfect. So hello, sorry. Hello, everyone. So I would like first to thank Data Week organization, BDVA and Luis for giving us the opportunity to present the project Platoon. Wait, I cannot access this. And yes, I will not be able to have my camera to avoid problem with the connection. I have an unstable connection, so sorry for that. So I am Philippe Calvez. I'm working at ENGIE and more specifically at the research center. And as Platoon coordinator, I'm trying to give you a quick presentation of this project in the next 15 minutes. So next slide, yes. So the title of the presentation is, as you can see on the screen, End-to-End Interoperable Ecosystem for Energy Value Chain. Indeed, the Platoon project seeks above all to illustrate through the ability to create a digital ecosystem based on a reference architecture that the partner will share and implement, and that embeds the key principle of Platoon. So the first one is interoperability. The second one is data. Wait, I have my. Where is my mouse? Just wait. The second one is data secure transfer and data-driven analytics services. And it allows the actors of the project and the end user of this energy value chain and the people who are pushing for the use case to implement the ecosystem with the technical brick of the choice. So that's a complete different paradigm. So we are providing more an ecosystem that a complete ready platform. So the objective is to focus on the end-to-end approach. That's one of the main advantage or goal of Platoon. And in Platoon, for example, there is already 3 sub-ecosystem or platform that are addressing the different pilot and use cases, and they need to be compliant by design with the Platoon reference architecture. So this is a quick presentation of Platoon, the ID card, let's say, of Platoon. So we started in 1st January 2020 for 3 years. So we are almost halfway here on the project. And the project focus on digitalization of European industry and services, and mostly on the energy value chain. And we are represented here with 20 partners from 9 countries. You can see the countries, we are quite spread. And the participants of the project are here with the logo. So we have utilities, energy actors, research center, end user, and as well SME and cluster of energy bus, for example, it's a cluster. So that's our partners. So what drives basically the Platoon project in order to understand the energy value chain is very complex, and it's encompass many, let's say, socio-economic sectors. Basically, when you have human activities, there is often in some way or somewhere an energy dimension to these activities. So this value chain, some of you already knows, is undergoing a profound transformation, particularly the following changes that you can see on the screen. So there is a big need of decentralization of the production and a massive decarbonization of energy production sectors. There is an increasing role of renewable energy, and due to the characteristic and the uncertainty of this way to produce energy, it requires some specific computational processing in order to predict the production and see as well the impact on the different energy infrastructure. And all this change, it's boosted by an increasing as well important role of the data. So there is along the value chain, because the value chain is complex, a massive increase of this amount of data, and they need to be manipulated and exploited, and particularly to be able to extract knowledge, which is not so easy. So the Platoon objective, we have a very, very strong focus on the first point. It means how we are able to provide fair and secure extraction of knowledge from the energy sector data. That's a very, very key approach from Platoon, because we focus on this digitalization. We think that we can create new business models that this approach and technological bricks, interoperability, sovereignty, and analytics can use this data, massive data, to provide the energy sector a new way to a new business model. There is as well on the third part a key component, which is the exchange of data and the representation of the data. We will come back to this later, between different multi-stakeholder and multi-tenant along the value chain. So with the different roles associated, data owner, data provider, data user, and so on. So we will try to contribute to standards, and we will need to be compliant to some of them, like COSMAC, for example, and provided interface that can leverage all this infrastructure of this ecosystem. So our use cases are not focusing on one specific part of the energy value chain, but they are along the value chain. So we have some pilot we will see in the next slide around everything around renewable energy generation, some pilots around smart grid transmission and distribution, and some end user pilots at the level of end user, cities, building, and so on. So here you can see our different pilots and partners. We always say 3 main blocks. So let's say the French-Belgium one, where we have 2 pilots, one of the predictive maintenance of wind turbine, and we are developing an analytics services, for example, for optimization of the wind-powered drivetrain, working as well on the digital twins with the VUB, NG, and Technalia. We have a pilot at NG on building, or we can combine, and we will develop services around this physical model and data-driven models in order to optimize the efficiency of the building, energy efficiency. Then it comes the Spanish block with a lot of different use case around building as well, and as well asset health diagnosis and focusing on grid. And we have the Italian one, which is combining different use cases on focusing on energy management system and efficiency energy for smart cities and building, and one on energy management for microgrid with Polytechnico. And we have a last pilot, which is there is a mistake. I will change the slide, but it's not predictive maintenance of wind turbine, but it's more analyzing the grid and providing machine learning models to predict the behavior of infrastructure of energy. Sorry for this mistake. So this is probably the key slide that I want to illustrate for Platoon, and how we consider this end-to-end interoperability for secure data analytics services for energy value chain. So everything starts or is consolidated at the level of interoperability. We had a strong focus last year on building this interoperability layer. So it means to be able to share representation of the data between different partners, different services. And we think that without this, let's say, these languages or common reference data representation or framework that forms a glue, it will be difficult to develop these services that you can dispatch in different pilots. And that's why we had a strong focus on this. And once you have done this part, yeah, okay, you have the data, you have the representation of the data with a common representation. You need to exchange in a secure way. So it comes the data governance and security, and we rely on a key component here with the help of Fraunhofer, which is a partner of the project on IDS connector. And so we package the data with the representation in order to share between different roles of actors along the data value chain for this case, and to send, for example, data from one partner to another partner that will perform some analytic tools and send it back in a secure and sovereign way. And the last one, once you have these two first pillar, I would say it's good, but you need to develop some services because you need to create value, and it's go through these services. And we developed a data analytic toolbox based on the different use cases that we are doing in energy for energy value chain, and we provide as well edge computing capacities in some use cases. Next slide, and 9 minutes, so we need to accelerate a little bit. So the first part of interoperability is focusing mostly on developing what we call, as a marketing world, core semantic data model, but it's, let's say, ontologies. So we have a complete pipeline and a methodology to extract based on the use case definition, which are standardized, or we can look for existing because we reuse or extend existing description or ontologies. We mentioned SAREF or CIS, or there is other that match the requirement from the use case, because some of them are not sufficiently extended to match our use cases. So we develop this, we extend it, and at the end we provide, let's say, core semantic data models that are provided to every pilot, and the different pilots use this core semantic representation to enter data and to perform analytics on this common representation. So that's the first point, and it took some time for the people who are doing this. I know it. It's not an easy part, but it's needed. And to illustrate how we are doing this in some pilots, this is a pilot 1A on wind turbine maintenance and prediction. We have a data provider, which is ENGIE, and ENGIE provides some data descriptions that are coming from our wind turbine, but are not matched in this, let's say, core semantic data model. So we extended this core semantic data model based on standards in order to match our data and to prepare it to provide to some other actors of the project that will perform as well development of specific services. And in this case, we send the data and the representation with IDS connector to the VUB, who will develop some specific application around anomaly detection. And this data will be exchanged as well in order to have a very good performance on this anomaly detection with the digital twins approach that Tecnalia is developing. And they will exchange together the data that are output from the previous model, and Tecnalia will run some model on their side, and will exchange back. Everything is using our core semantic data models, and at the end, output are coming back to ENGIE, and we have some services around wind turbines that will use this output. So that's typically one pilot, but it can be these services, because they use the same description of the data, can be used in other contexts, in other people or other provider of data with wind turbine, or another provider for anomaly detection can provide these services and map with the core semantic data models. That's where we say it's interoperable. And these services can be, because we have some Dockerization on the services, can be embedded as well, can be in the cloud, can be at the edge, can be on premise, depending on the requirement of the different stakeholders of the different project. So here in the slide, you have a view on the different services that we will develop at the end of this pipeline. So it's very energy oriented, but some of them will be tested, will be developed in one pilot, and will be tested in other pilot, trying to prove that can be interoperable. And when you are considering that in some pilots, they are not using the same, let's say, IT platform, the IT platform is matching the reference architecture of Platoon, but it's not the same. It gives you a feeling that you can deploy this kind of services in other ecosystem that are matching the reference guideline, and it works out of the box because they are using the same approach, and most important, the same representation of the data. So I have 1 minute normally in my, so it's good because I am at the last slide. So last slide, so end-to-end interoperable digital ecosystem for energy evaluation, we consider, and I think it's a sharing point of view on this, it's not just about doing interoperability, doing knowledge models, ontologies, and so on. If they are not used and if they are not shared by the community and expert, it means open source, they will not be implemented in real life in context of enterprise, because it can be done at the academic level, but it needs to have a reality. People need to use it And in a company, we say like NG, you need to convince people to use this kind of approach. It's not so easy. So first, it's not just about describing model and try to make them interoperable, but it's very critical if you want to do it. And then once you have this, you need to exchange data, but exchanging data and the people in both sides are not able to manipulate it with the same representation, then you have another issue. Are able to exchange the data, but you have not the same representation. And at the end, you need to build services, but these services, if you have to develop every time the service or extend a little bit to adapt to a new context, the data are not the same, and you know all the time that it's never the same. Yeah, you have some problem. You cannot replicate, you cannot scale, and it's not portable, interoperable, and so on. So that's why we think that with this approach of Platoon on the use case, we try to demonstrate this end-to-end interoperable digital ecosystem. It's an ecosystem, and when we will publish, people that use this reference architecture should be able to be interoperable with other systems that are using it. So that's it, 16 minutes. So if you have any question, last slide, you can follow us on this different channel, send us a tweet and LinkedIn and like everybody. And if you have any question, you can send me an email. My email is here, and I will be happy to answer you. And if you want to collaborate with your project or for further projects, let us know. That's it. Thank you very much.
Thank you very much, Philippe, for bringing your insights and sharing with us the Platoon project. Then we are going to move to Javier Baliño. Hello, Javier. I have to ask, we are a bit with a bit delay, just to the three remaining panelists. I know it's not fair, but please try to speed up so that we can have some room for the Q&A session. So, Javier, the floor is yours. Javier?
Sorry, I was trying to unmute myself and I didn't find the menu, but hopefully you can see me, hear me, and see my slides, right?
Right, thank you very much.
Okay, great. So I will try to go a little bit faster, so no problem. And well, as you can see, this is a similar presentation regarding BD for Open Projects. So I am just about to tell you how are we tackling these challenges in terms of data management and also end-to-end security for our project. And I will start with a brief presentation of the project itself, and then I will follow with things that we have already implemented, trying to solve these challenges, and also a glimpse of what we intend to do in the second phase of the project, because you know now we focused so far into the architecture and also the definition of components and so on, and now we are moving to the real development phase. So what are our plans regarding this? I wanted to start with this picture, which is taken from IRENA, in which they are somehow setting the scene for what artificial intelligence and big data innovation activities are being done along the energy value chain. So as you can see, there are a number of activities. Some of them are closely related to a particular part of the value chain. Some others are more cross-cutting. I just wanted to show this slide because I guess like all our sister projects that we will see in this panel today, we are focusing more on the distribution and retail part, and therefore we are trying to solve these issues or these challenges that are marked here. In one or another degree, maybe, but the one on purely on generation, but it is good to see or to set this thing this way in order to see what are we talking about. And well, just regarding BD for Open project itself, as you can see, it is a project which is made up of 12 different partners from 9 different EU countries. And regarding objectives, our focus is on distribution grid, as I already said. with large renewable penetration. We are trying to investigate how to make the most out of the data that is currently being gathered, and it is most of the cases underused, and try to use it for better planning, maintenance, operation, and control. In order to do so, we use data science and data analytics. As you can see on the conceptual architecture on the right-hand side of this slide, the center part of the project is for the data analytics toolbox and marketplace we are developing inside the project. And we are trying to link this central part with some data providers on the left and service providers on the right. So we will be interacting with them at different levels with this toolbox and marketplace. Our data sources are mainly our pilot sites, which are complemented also with different open data sources at the European level. And project partners are developing a suite of analytics services on top of this data, covering a range of different functionalities, as you can see, such as topology and observability, error detection, network stability, load detection and impact, aggregator flexibility calculation, energy management systems for houses, buildings, and industries, cybersecurity and peer-to-peer trading, and some more generic, let's say, tools or business-oriented tools, such as asset and investment planning or KPI and indicators generation. So that's in brief the objectives and how are we organizing the work in BDVA. I will start with a couple of slides regarding what we already did. As you can see here, this is our architectural approach so that we can compose a software system addressing all the aforementioned challenges. It is not revolutionary, as you can see, and it is closely related also to these GAM interoperability layers that are also used, for instance, in Bridge for the conceptual architecture. So we start in bottom up. The physical layer is just for the data provision, and in which or through which we are enabling also the different communication protocols. One step higher and directly going into the BD4 Open platform. As you can see, the physical layer is outside, let's say, our developments. And through these means of communications with these communication protocols, we are trying to build a data layer in which we are placing the distributed storage, and it is in charge of data mediation, access, harmonization, governance, and quality management. So purely data management related things without or taking out the security. We will see how we tackle this security and privacy outside this layer. Then if we move up, we go to the analytics layer, which is the one in which we are trying to provide services valorizing the data which is being gathered through the data layer. And you can see here that this is the placeholder for our distributed analytics engine, the resource monitoring, the KPI detection, the management of analytics service, and the value-added services. On top of all these layers, we are placing a marketplace, both for services and data. And it is important to mention that this would be a marketplace B2B2C. So we are considering both business to business and business to customers. And it provides the interface among the offered services and the actors involved. And by actors, we mean data providers and data users. And finally, as you can see, we placed a cross-cutting security, privacy, and blockchain layer, which is also where most of our innovative modules are going to be placed. We are trying to provide through this layer secure access and authorization. It is also the layer which is in charge of security and using public cloud solutions. And we are using it for our blockchain also related services and the blockchain layer that we are developing through the project. Trying to go into a little bit more detail of what we already did. This is regarding purely the data management activities. So as you can see, we did already an exercise of trying to anticipate the protocols that we will be using, and therefore translating them into a comprehensive common information model. So this is something we already did. So in terms of data management, let's say the first step has been the identification of a comprehensive common information model based on well-known standards. As you can see on the right column, we used a number of well-known ontologies. And now we have this common information model in place, we can start developing our innovative module. So from this point on, I will start talking about the future, let's say, and our plan for developing the modules that are directly interacting with data. So this was the part regarding data ingestion. And as you can see, our intended way forward to achieve the technical challenges regarding data usage is using Apache NiFi adapters for data ingestion that are supporting multiple protocols and authentication options. And we are including here also the security information and event management. Then it is worth mentioning, as I already anticipated, that we are using a public cloud in order to address the solutions from our project. And the good part regarding this, our selection of Azure enables us with some ready-to-use security mechanisms such as CM, as we already mentioned, firewalls, Active Directory, encryption, TLS, and so on. And we are using an API gateway to enable this interwork with our services on top. This slide shows real-time access and use of our unified API to real-time data, as you can see in the figure, but also persistence data in the data lake we are deploying as part also of the data layer. The use of this unified API module means that any underlying technology could be swapped out or replaced without affecting the services implementation. And for example, to change the persistence data lake provider or the context broker for alternatives in the future. Then this slide is about SSI components, which are based on hyperledger areas. This is the blockchain part we are developing. The SSI wallet is the mobile application that will be used in BDVA Open Marketplace across actors, for instance, service provider administrators, data provider administrators, service users, data users, etc. This SSI agent runs a server inside in the role of issuer, holder, and verifier, and it is composed by a controller and a hyperledger areas framework. Every agent can contact accordingly to more of one of the canonical SSI roles, so such as verifier credential, issuer, holder, or verifier. And this SSI decentralized ledger is the tool used by the areas agents to store and retrieve information on the distributed identifiers, information contained in a specific JSON format following the DID W3C standard. And this process in the SSI community is named DID resolution. In the figure, this combination is performed by agents to ledger represented by dotted lines, and depending on the available ledger technology, the implementation may use the ledger also to manage the schemas of the BICs schemas and the revocation of the issued BICs. And the information crypto key is held in a specific JSON document named DID document. So, well, just in brief, what you can see here. So that's all I had to say in brief, and I will be happy to answer questions either now or offline. Sorry, I had to hurry up through these slides, but I guess more or less it gave you an overview of what we are doing and what we plan to do in the next future regarding data management and security and privacy. Thank you very much.
Thank you very much, Javier. Yeah, indeed, thank you very much for bringing your inputs from BD4 Open project. Okay, so just to continue moving fast, I will give the floor to Natalie. Before that, just remember, please, to go to WOVA poll section, okay, all attendees, so you can give your opinion, okay, and that's it. Thank you, Natalie, whenever you want.
Yes, hello, good morning, everyone. My name is Natalie Samovic. I represent BD4Energy project today. We are a new kid on the block, so I will focus on the future vision that we have in the project. In the project, we manage one of the large-scale pilots. We're located in south of Portugal, so we manage research and innovation platform and the related renewable infrastructures. It was great to see the progress of the preceding projects in our call. This is the reason why I mentioned that we're a new kid in the block, because we just started January of this year with the project. So we have advantage and the disadvantage. Advantage is that during this period, a lot of new information came up, new thinking, and the white papers by the organizations such as IDSA and Gaia-X that we already can reflect upon and take into the consideration, and also see where the leftover challenges, let's put it that way, of the other projects. So, but BD4Energy, as you can see on the slide, started January of this year. We have 35 partners from 11 countries. So we do focus on the large-scale pilots implementation and the so-called two-way co-creation of services. So we have TSOs, DSOs, aggregators, ESCOs, distributed communities, market operators, and SOE, and ICT service providers. So it's a full value chain. In terms of the differentiation and the add-on, let's put it that way, we are aiming at putting up together a so-called BD4Energy analytics AI-driven toolbox for the solutions and the underlying big data management framework, also with a number of components to facilitate these services. The other angle that I think is project differentiator is the cross-domain data leverage and driven solutions, which are bottom-up driven. And another angle is also related to the edge systems and edge-driven architectures, which are evolving, and we are focusing on this, on the creation at the edge. So, so the 12 large-scale pilots serve as the validator of this approach, and as well as the co-creator of the services. So the last point you see here on the slide is near real-time energy efficient and user comfort management, optimized risk assessment of energy efficiency investment as well. So all angles, not only grid perspective. So why these services and big data driven solutions are of essence? If you take the system approach, all the nodes are both contributors, users of the services, and as well as the co-creator. So when we are talking about system level vision, this is what we mean. So it's a multi-way and multi-sided approach. So also, as I mentioned before, the hybridizing energy versus non-energy value chain is part of the project objective. Of course, we all know as to the challenges and opportunities of the decentralization of renewable generation, and also the electrification, further penetration of the electrification. So here the challenges of the cross sector and the cross domain come in as well. and of course to address the increasing demand for the flexibility overall, and as well as the creation of the flexibility services marketplaces while keeping the consumer centricity in mind. So where are we as the project? And here you can see some of the things that I mentioned and the initiatives that we're already taking into account. So we're at the stage of the finalization of the use cases and the services creation while working on the toolbox. So we're really in sync with the upcoming and EC data strategy, and you see some of the initiatives that we're taking into account, such as IDSA, Fireware, Open DI, GaiaX, and LF Energy, and we see this relationship as a two-way, so taking into the account and as well as contributing to. So here, I know it's a thick slide, but this is our original vision. So I will just share four main goals of the project. So we are aiming at developing data-driven interoperable reference architecture for AI-based edge-oriented scalable big data management and analytics in smart energy grids. So once again, you hear the two main focus areas, AI and the edge analytics. Within this context, we're aiming to develop and deploy IDSA compliant hybrid IoT off-chain versus the blockchain on-chain decentralized data governance as an enabler to facilitate open B2B cross-stakeholder data sharing within the trusted data exchange and the related handling. Some concepts were already shared, so I think we were going along similar lines, but see how it will evolve based on the large-scale pilots. Which we expect will allow data sovereignty and control of the respective data ownership, access, security, and protection. The second goal we have is related to adaptation, evolution, and the upscaling of the advanced edge AI-based big data management, learning, and analytics. So again, the principles of the privacy-preserving federated learning, cross-stakeholder transfer are very much on the forefront of their requirements, and as well coupled with dynamic self-learning within these architectures. The third goal is to upscale and deploy what we call open modular energy analytics toolbox that I mentioned at the beginning, along different modes, where we are aiming at and designing right now experimental on-premise sandboxes, and as well as the so-called toolbox as a service across a number of toolboxes or pilots. The fourth one is to develop an open tokenized peer-to-peer blockchain marketplace. So this marketplace aims at incentives-based asset sharing, trading, so incentive-based asset sharing, all kinds of assets as the services, as well as the access to the assets, trading and exchange, and including data, computing, ICT assets versus energy and energy assets. And the fifth one is to validation. As I mentioned, the 12 large-scale pilots provide very heterogeneous environment, and the validation of the BDVA toolbox and underlying reference framework. So I won't go into all of the details related to each of the components here. So, but just to mention, We are focusing on the governance, and here I think you will see a number of the familiar standardized data gates such as SAREF, ETSI, Fileware, Context Broker, and GSI, and SIM. So what we're aiming and incorporating is the policies and mechanisms of IDSA, Gaia-X, and enabling data sovereignty as well within the concepts that I mentioned. So proceeding on related to our architecture within the processing layer, there are also some innovative approaches, once again, edge-driven innovative approaches that we're experimenting with and will be offering. Moving on to the analytics, I think I gave some insights as to the toolbox approach. So an analytics service builder for the reuse of business logic capabilities on the selected data set is one of the goals. And of course, the visual analytics as well to go along. I'm going very quickly just because I know we have time constraints. So a little bit more details on the application level. So here we're aiming at the so-called virtual workbench to incorporate the assets, including data, third-party services, machine learning models, computing resources, storage resources as tradable assets. And I think I already mentioned the tokenization component for the marketplace. So here is just the snapshot of how much more complex considerations for the both architectures and the services became. So here on the left, you see some of the logos of the initiatives that I already managed that we take into account and participate in. And on the right hand side is three components that we anticipate to be contributing to. Just to give insight as to where we are right now and what we're doing other than the use cases and the toolbox creation. So we've undergone an extensive exercise of the mapping and alignment. And here are some of the initiatives where we've done the mapping and alignment too. So IDSA principles for data spaces design. Also leveraging the Fileware Smart Grid vertical reference architecture and the specifically cross-sector data sharing spaces approaches. So we also think that the BD4Energy will be able to get one step closer to the data spaces for energy based on the big data components that I mentioned. That was in the previous slide. And of course, we hope that it's going to be a booster for the Gaia-X, where we hope to benchmark and validate Gaia-X requirements towards energy data spaces. And as well as we're taking into consideration Gaia-X architectural vision for energy vertical data space. As to the edge components and edge architectures, so we are collaborating with AATI on the edge architectures and the marketplaces. So there are a number of upcoming reports specifically on the connectivity of the edge to the Gaia-X and linked to IDSA principles that is being anticipated there. So this is just very quick one example of the mapping on the bridge SGAM. So just this image gives a snapshot on where we see things and what's the overlap in terms of the services and the use cases that we anticipate in the BD4Energy. We do have open calls and cascade funding, so looking forward for the collaboration and as well as the future synergies between the projects that presented today as well. Thank you so much and looking forward for the questions.
Thank you very much, Natalie. Without further delay, I'm going to give the floor to Ruben, who is going to enlighten us with some insights from the Portuguese ecosystem, so we can leverage the opportunity as Portugal is currently holding the EU presidency and also is collaborating in the organization of this event with BDVA. So please, Ruben, whenever you want, the floor is yours.
Okay, Luis, thank you very much. Good morning, everyone. So let me just share here my screen. Okay. Okay, so thank you very much for attending this session. So my name is Ruben Costa. I'm also working in Synergy, basically representing here KnowledgeBiz, and we are leading here the matchmaking and recommendation service for the Synergy project. So just go very shortly about KnowledgeBiz. So KnowledgeBiz, it's a very, I would say, a small company, a spin-off company from the University of Lisbon. It was basically founded in 2006, and our domain expertise it's on ICT, big data, and AI. So the outline for this presentation, I'm basically making here two separations. I will just briefly describe a little bit on what is actually our role inside the Synergy project, what we are actually proposing for Synergy, and also as Luis already mentioned, also to provide here some glimpse about what kind of projects which are mostly dealing with big data, what kind of projects are actually running here in Portugal. And I must confess that making this kind of separation of Portugal, it's very difficult because we are all connected. So saying that this is something that it's only being implemented in Portugal, it's very difficult because, as you will see, this works as an ecosystem of several entities, most of them also outside Portugal. Okay. So basically about the recommendation and the matchmaking, what is the overall of this recommendation, why it's important, and also related to Synergy project, why it is important to also have this kind of value-added service to the I would say the stakeholders, the end users. Basically the idea here is to predict what are the user interests and also recommend them. What are I would say the items, or in the case of Synergy, what are the data assets which are more, I would say, interest to this kind of users. Why is this important? Well, first thing, to speed up searches. This I would say the first most important thing. Also, to make easier for users to access the content, in this case, the data assets, which are their interest. And I would say that the third interesting point, it's also, I would not call it surprise, but also to award users, or to also offer users also new data assets that users were not aware of it. About the expected results, of course, we should also look this into a commercial perspective. And here is the idea of course, increasing sales, to also enhance customer experience, gain and retain customers. Also from the user side, so the user can get, I would say, more interest in using our platform because they know basically we are giving, or we are providing users what they are requesting, and also to have a competitive advantage, and also losing the threat of losing users, or in this case, losing clients. About the data, what is basically the data that we are addressing here? In one side, we have the user behavior data, which is basically we are learning user behavior, clicks, views, downloads, the interaction of the user with the platform. So this is something that it's being acquired. We have also the user profile data. So basically data about the user, about the type of organization. So if we are basically consider here a DSO or a TSO, probably they have different needs, and the data that it's going to be provided for them in this perspective, it's going to be different. And of course, we have the data itself, okay? The data that the platform is managed will be managed. This is also the data that we are going to present to the user. We have different recommendation techniques, for instance, popularity based. The idea here is to recommend what are the most popular items to users. We have the collaborative approach, where basically here we try to some extent to cluster users in the same group. So basically to identify users that have the same tastes, the same, I would say, interests, and then to present this kind of users new data assets. And as another approach, we have the content base, which basically looks inside the data itself and try to look into similar data items and then present to the users. One very important example that I also like to highlight here was, for instance, the Amazon. So the Amazon starting as selling books, but actually what triggered Amazon was the recommendation engine that was running in Amazon. So providing new suggestions and new recommendations to the end users. Going a little bit fast here on the implementation. So just to highlight that we are having here, I would say, two different phases. One is the indexing phase, which we are basically indexing the data assets. So we are creating a database where we are creating index for what are the available data assets that are able to be looked and to be searched using our platform. And then on top of this indexing, let's say, algorithm, we have the recommendation. So this is where the recommendation plays a part, where we are using similarity-based algorithms in order to provide, I would say, the best match items to the users. So first phase, it's about indexing. The second phase, it's about recommendation. One also very important aspect, so because this is a dynamic process. So the popularity items which are popular today are not popular maybe tomorrow. And this in this also, we need to take into account this. So it means that we need to re-rank and re-index the items, I would say, in a daily basis, because this is something that needs to be integrated and processed every time. But this boils down into a very important aspect, which is the aspect about data sharing. Data sharing was an important, I would say, dimension that was mentioned in all of these presentations that we had today. And data sharing could be a trigger for inducing behavioral change in people. And I would like just to present this research that basically by sharing the data, one company, one small energy provider in the US, they were able to induce the user behavior in basically making them more energy aware and energy efficiency. What they did was basically to share the data of the neighbors between themselves. So there was here a kind of competition between a neighborhood in order to see what was the people, what was the person, or in this case, the house that was more, I would say, keen and prone to be more energy efficient. Okay, so basically the idea, it all boils down into a data sharing philosophy, a data sharing principle. So I'll just now provide a very, very short glimpse about what projects are running in Portugal and projects which are basically specifically dealing with big data and AI. Of course, I don't know the majority of them. I know some of them, but in any case, I would like to present them. What I consider could be, I would say, the champions in this area. So we have these XFIT. So basically, XFIT is a project that is running by EDP and General Electric. So EDP is the Portuguese DSO. Actually, not the Portuguese DSO anymore, because they basically separate between the Portuguese DSO and the Portuguese commercialization of the electricity. And now EDP focus on the commercialization part. But this is a project that it's running also on an EDP, and it's dealing with predictive maintenance. So once again, dealing with data, dealing with artificial intelligence and predictive analytic tools in order to monitoring equipment performance, and I would say as a goal to anticipate risks and potential failures. Another project also running by EDP, it's also to predict the generation and the consumption of real-time in all grid assets with telemetry. Once again, here the usage of big data technologies in order to forecast in real time the consumption and the generation of all grid assets, including also load diagrams. This is an H2020 project, which is run by the Portuguese TSO. And this is called iEnergy, which stands for Artificial Intelligence for the Generation of Energy. And this has a demonstration scenario, demonstration pilot running in Portugal, which is basically divided into dimensions. One, it's the application of AI for predictive maintenance, integrating off-grid data with condition-based monitoring. And the second dimension of the pilot running in Portugal is to use, once again, AI technologies for the network loads and the demands forecasting using an efficient operation planning. This is a 5.6 million project with a three-year duration. Another project also dealing with energy efficiency. This is called POCTF. Also, we have an interest demonstration pilot running in Portugal, actually in the city of Évora, and it's focusing here on positive energy buildings, where 3 different demonstration scenarios are being run in Évora. One in the city itself, another one in a village nearby Évora, and another demonstrating scenario running on industrial and a commercial park, where the idea here is to make buildings, I would say, more energy efficiency. Another project running in Portugal, Llanos. So this is running in Azores, in the island, and the idea here is to come up with the development of a virtual power plant based on artificial intelligence. I will speed up now very fast because I know that the time is running. Also another project which is running by RH, which is actually the Portuguese DSO of 14.5 million projects, also dealing with the application of big data and AI in order to make the integration of renewables and also to engage the consumer participation into an interoperable market solution. Another project here focusing once again on the islands. This is focusing on the Madeira Island, which also has the participation of EFASEC, which is basically, I would say, the builder of energy components. Another project also running in Portugal. The idea here of this project is to encourage the energy consumers to become more active actors in the energy market. Sorry about my voice, I'm losing my voice, but I think I'm more or less to finish. Another project called OneNet. So this is a big project, 27.9 million projects. Also, we have RH, which is the DSO, which is the technical coordinator of this project. And here the idea is the implementation of a wide range of flexibility mechanisms to address both DSOs and TSOs needs. Okay, and basically this is my final slide. I would just like to pinpoint here some values, some figures about, I would like to draw your attention to 2 domains here. One is the ICT. You can see here on the left side, where we have the participation of Portuguese companies on the energy sector, on the energy domain, 390, but also on the ICT, 302. And if you look into the right side, we have here the funding in millions. Also, energy and ICT, I would say, are the two dimensions which have more funding and more participation of Portuguese energy players here. So thank you very much. Sorry about my voice, and I'm more than happy to support you if you have any further questions. Sorry, Luis, if I delayed too much.
We cannot hear you, Luis.
Luis, we cannot hear you.
I'm afraid I cannot hear you. I don't know why.
Yeah.
Can you hear me now?
No, yes.
Yes.
Okay, perfect. Thank you, Ruben, for your presentation, from your insights from the Portuguese ecosystem. I have, although we have run out of time, I have good news. Ana Garcia, our host from BDVA, has allowed us, let's say, to have some more minutes so we can have our questions and answer and work of a session. So let me check the questions in WOHA. If there are none, then I will publish myself some questions we have prepared. So I'm going to publish them in the Zoom chat. And I will ask all the panelists to switch on your microphones and cameras. Okay, so we can have a more dynamic, let's say, session. So the first one is well, which are the most challenging technical problems for your project? So if there is anyone that wants to start answering this question, please feel free. Otherwise, we'll start from the beginning. We can have we can follow the same order that we, the same order of the presentations. So, okay. Let's give the floor to Fenaretti, if you don't mind. Do you want to provide us with some insights here?
Definitely, Luis. I will provide just very, very brief words. There are many challenges that need to be tackled along the way when we talk about real-time data collection, data processing, data analytics, when we talk about certain restrictions that come from the stakeholders and what type of impact they have on how certain things happen. The restriction that the data must be always stored locally, but when we talk about sharing and running analytics, how this can be, let's say, brought together with certain technical restrictions, the part about the multi-party contracts and how we enforce the terms of the contracts along the way. It is just some very, very indicative examples and the let's say the top of the iceberg on all the things we have been dealing with over the past months. I don't want to take any more time. I would just like to give the floor to the rest of the partners to also provide their perspective as well.
Thank you very much, Fenaretti. So, Philippe, I don't know if you want to share your vision on this question.
Yeah, of course, it's the same. We have multiple challenge, but one of the main challenges probably is that you can find in the other, it's around the data, or you are able to get access to data from different sources, the heterogeneity, and or you build this interoperability layer that people can use end to end. That's probably, so it's not only you describe the data and you use it, but you remap in your system. And after you lose this kind of description, there is a big challenge of keeping this description end to end when you process the data with the description, you give an output, but you describe it in a way that it come back and enrich the previous description. And it's probably something that we will try to address. I don't know if we will be able to address in all pilot, probably not, but this complete end-to-end, enrich the knowledge that you have, extend the knowledge based on data and inference and so on, based on your different services and pilot. That's probably the main challenge from our project.
Thank you very much, Philippe. Then Javier, if you want to participate as well.
Yes, sure. So, well, apart from both things that Fenareti and Philippe already mentioned, I would even go one step back, let's say, and it is also challenging to try to convince data providers that it is meaningful for them to share data, because most of the times they are saying, okay, this is my data, I can valorize it. What are the benefits of sharing this data with others? So identifying the meaningful data to be shared, keeping the security and privacy of the data that we are sharing, and locking, let's say, or limiting the number of stakeholders that are accessing this data. So this is also challenging, making sure that we indeed are able to do something on top of what everybody can do on their own data, and convincing everybody that this sharing is beneficial for everybody.
Thank you very much, Javier. So, Natalie, do you want to share your vision?
Yes, well, besides the vision, we already have the challenges as well. So building on what Javier mentioned, of course, data valorization within the context of smart sector integration is, so building on the even wider scope of it, so not even within the players within the electricity and energy, but the cross domain is because expectations are different, and the multi-speed of the development is also there, besides the technical data share challenges out there. We also anticipate that there will be a discussion between the differences, data marketplaces versus data spaces. You know, do people want to trade data and services, or create the data spaces as the alternative to marketplaces? This is something that came up in the discussions. I wouldn't say that it's the technical vision, but we see some challenges and perceptions coming up there. And the last one, very quickly, on the edge, of course. So the edge architectures are just evolving, and solutions. So we are sort of, creating or anticipating some of the challenges while putting those in place. Thank you.
Indeed, thank you very much, Natalie. So, Ruben, if you want to elaborate on.
No, just very quickly. I'm totally aligned with what was mentioned by Javier. I think the value here it's key on all this. If we basically don't, if the end users don't understand what is the value beneath sharing the data, I think there is a huge barrier here. We saw that, for instance, in the recommendation system that I just presented. It's all about sharing data. The more we know about a customer, the more we can offer to them. And this is something that needs to be explained, not only for end users, but I think all the stakeholders. What is actually the value which is within the data sharing, I would say, philosophy.
Thank you very much, Ruben. So I think we have time for another question here in the chat from Jean-Christophe Pachaglia. Is the European regulation framework on energy ready to unleash the more innovative scenarios? And if not, what are the main blockers? So if any of you wants to start with this, giving his vision, her vision, otherwise we can repeat the process. Okay, so Fenareti, if you want to provide your insights, please. Please, you're muted, Fenareti.
Okay, now you must be hearing me. So what I was about to say is just a brief reference to regulation in general, not only the specific regulation, but in general, there are barriers that emerge from regulation or certain opportunities that may come along. And this is something that I think that in all projects, a certain regulatory analysis is performed in order to ensure that the technical results we provide is something that can be really used by the different stakeholders. And this applies to the AI regulation as well, that has been very recently published, but in general to any regulation that affects the work that we have been doing.
Thank you very much, Fenareti. Philippe, do you want to share with us?
Well, that's a complicated one on regulation. Yeah, probably due to this paradigm shift, that's probably historically it was energy was managed at the national levels, and now we are decentralizing the value chain locally, national, but it will be done at the EU level. Yeah, regulation will be a strong part, and you need to adapt in your infrastructure because it will drive the way that you deploy the thing. You will not be able to do everything. You will need to push to go further. But for sure, due to this shift paradigm with renewable decentralization at the scale of Europe, yeah, regulation will play and you can see as well with regulation on GDPR, it's not a regulation, but GAIGs, the policy rules and so on. It's some kind of, yeah, you are recommended to use this kind of stuff. So there is incentive to adapt technology to some context. It's not you can do whatever you want.
Yeah, definitely. Okay, Javier, if you want to let us know your opinion.
Very quickly. So building on top of what Philippe was saying, I think in terms of data sharing and privacy security, we are more or less ready. So that's one part of the equation, let's say. In terms of purely energy services, it depends from country to country. Some countries are already implementing innovative services on trading or using blockchain and this kind of things. Some others still are not allowing for this to happen, but hopefully we will converge in the future with a common view at the European level. So that's true. So maybe we can start using the less innovative part at the European level, let's say, while we wait for each and every country to shape the regulation so that we can use advanced artificial intelligence and innovation on top of the data that we can start gathering right now.
Thank you very much, Javier. Natalie, we will be happy also to know your opinion.
Very quickly, two aspects. We cannot afford heterogeneous approach across the member states for the unleashing of this. How is the innovative scenarios, let's put it that way, because if we're aiming towards the digital sovereignty and the data sovereignty, scale matters, and especially if we're talking about the big data, AI, and the the architectures that we're putting in place for the system of system vision. So this I think is the key. We have to be homogeneous in the approach. We have to be fast. Because these services are also part of the bigger picture of the decarbonization and the twin transition. So let's keep the big picture in mind and push forward.
Yeah, completely agree. Thank you very much, Natalie. And finally, Ruben, you want to have some words here?
Basically, yes. So I'm pretty much aligned with what was mentioned by Natalie. Regarding the regulation framework in order to foster, I would say, the application of renewables more and more within our, I would say, local economy. I think this should be one of the key aspects, and I believe, because the question also highlights about the innovative scenarios. And I think from I would say the summary study that I was able to do in the last couple of days of basically what are the projects that are actually running. Actually, I saw some very innovative scenarios that are dealing with the decarbonization. I think regulation here has a big role in order to foster this, to make this happen. Yes.
Thank you very much, Ruben. Okay. So I think we are running out of time. We have had a very tight agenda. I know I would like to be here, more and more time. All the questions remaining will be answered offline. So I would like to close the session, giving thank you to all the panelists. Thank you, Joanna, for your support behind the scenes, and also Ana Garcia and BDVA organizations for hosting us today and giving us the opportunity for the Big Data Energy H2020 projects to let's say, to share our insights here today with all of you. Thank you very much for your attention, and have a nice day.